Hi, friends. Welcome back to another exciting FOSS science story. Today, I'm going to be reading to you a little story called Digging It Up, Mining for Minerals. Okay, and as you can see here, you can always follow along with me here, or you can feel free to go read it on your own if you have this book at home, or you can follow along on the FOSS website. All right, so digging it up, mining for minerals, gold. The methods used to retrieve gold, to get gold from the ground and water, have changed since the 1800s. Gold lies underground in veins running through other rock. A tunnel is dug to bring it to the surface. Special machines crush the rock. The gold is then processed and removed. When gold erodes out of the mountains, it is carried away by water. It often comes to rest in stream beds. In earlier times, people mined gold by panning in streams. When sediment is swirled in a pan with water, the gold moves to the bottom of the pan. That's because it is heavier than other materials. Modern ways of collecting gold sediment still depend on its heaviness. Sometimes a stream of water is used to sort the gold from the sediment as it washes over special channels. Flat-bottomed boats with buckets are also used to collect sediment. The sediment is poured into a screened container, which is spun. Water helps separate the gold from the other materials. Gold is valued because it does not rust, wear away, or lose its bright color. It is soft, so it can be hammered or rolled into very thin sheets, stretched into wires, or shaped. To make coins or jewelry that will last, gold must be mixed with other, harder metals. Gold is also used in dentistry and medicine. Gypsum. Gypsum is a soft mineral left behind when seawater evaporates. In some places, gypsum deposits are very thick. To reach a gypsum deposit, it may be necessary to remove a surface layer of mud or soil. Next, gravel and rocks are removed. Then holes are drilled for explosives. Front-end loaders take the chunks of blasted gypsum to be crushed. Wow. When ground gypsum is heated, a fine powder called plaster of Paris is left behind. And just so you know, plaster of Paris is something that we use in our Ancient Societies unit when we make masks, which hopefully we'll have an opportunity to do this spring. When it mixed with water, plaster of Paris quickly swells and hardens. It is useful in making casts for things such as dental plates, ceramics, and statues. Gypsum is also used to make wallboard for building construction. Bauxite. Bauxite is a soft mineral found in clay. Bauxite deposits are found on or near the Earth's surface. In open pit mines, mechanical shovels or rotary bucket excavators dig out bauxite. The bauxite is crushed, screened, and milled. Then heat, electricity, and a chemical process separate aluminum out of the bauxite. Aluminum is a useful metal. It is 3 times lighter than steel and almost as strong. It is a good material for building bridges, aircraft, bicycles, and cars. Because it does not tarnish or rust, aluminum is made into siding for houses and hulls for boats. It is also formed into wire, insulation, cans, kitchenware, and foil for wrapping food. Iron. Pure iron is soft. It becomes stronger when it is mixed with other materials. In ancient times, iron was used for ornaments, weapons, and tools. In the 1800s, it was used to make railroad rails, train car wheels, nails, and machine parts. Now, most iron is used to make steel. Steel is good for building because it's very strong. It can be shaped into sheets, wires, beams, and pipes. Steel is used to make tools, blades, and cooking utensils. Iron ore is often collected from open pit mines. The rock is broken by blasts of dynamite. Hydraulic power shovels lift the ore into huge trucks. The ore must be crushed and smelted to extract the iron. Today, we use planes to find iron. The planes carry magnetometers, which sense changes in the Earth's magnetic field in places where there are large iron deposits. All right, and I'm going to pause there because the next thing we're going to be reading is titled A Mineral for Each Month. A mineral for each month. Birthstones. All right. For a long time, people have identified stones with the months of the year. Such stones are called birthstones because each represents a month in which a person was born. Most birthstones are crystal versions of minerals. When cut and polished, they can be used as jewelry. At one time, people believed birthstones could protect, heal, or bring luck. Sometimes magical powers were associated with the stones. Though these ideas are not true, some people still believe them. So let's find out about each month. January. January is garnet, often colored red. Garnet crystals form easily in rock. They need no polishing. Long ago, people believed in a garnet would protect its owner from wounds. February. Amethyst. Amethyst is a form of quartz that's purple. Amethysts were once thought to keep soldiers safe in battle. March. Aquamarine. The mineral beryl forms crystals of different colors. Blue ones are called aquamarines. Aquamarines were supposed to bring good luck to sailors at sea. April. Diamond. It takes extreme heat and pressure to turn carbon into diamond. Diamond is the hardest natural substance in the world. Some people believed a diamond would give them unbeatable strength. May. Emerald. Unlike many other gemstones, emeralds are not found washed into streams. They must be mined from other rock. It was said that an emerald placed under the tongue let one see the future. June. Alexandrite. Along with pearl, alexandrite is the birthstone for June. This mineral is both rare and unique. In natural sunlight, it looks green, but when lit by a light bulb, it appears to be red. July. Ruby. Most rubies are found mixed with sediment in stream beds or under soil. It was thought that a ruby turning dark warned its owner of danger. August. Peridot. Green and yellow-green peridots are forms of the mineral olivine. They can be found in lava flows and in meteorites. Peridot is the only gemstone from outer space. Peridot was said to give its wearer dignity. September. Sapphire. Both sapphires and rubies are really crystals of the same mineral, corundum. The presence of different elements make rubies red and sapphires blue. Legend claims a sapphire will make a foolish person wise. October. Opal. Opals are a kind of mineral gel that contain water. Opals can be clear, cloudy, or opaque. Opals of good quality may show rainbow-like colors. The Romans wore opals for love and for hope. November. Topaz. Pure topaz is colorless. The presence of certain elements can make topaz yellow, blue, green, orange, or pink. In the Middle Ages, topaz was said to improve the mind. The largest known topaz crystal weighs 271 kilograms, which is equivalent to 596 pounds. December. Turquoise. Blue-green turquoise is an opaque stone that is rarely found in crystal form. Native Americans of the Navajo tribe believed a turquoise thrown into a river with a prayer would bring rain. And here we see scratch match. The diamond is the hardest birthstone. How do you think the other birthstones measure up? Here is a list of birthstones from the hardest to the least hard. Diamond is the hardest, then ruby and sapphire, then topaz, alexandrite, aquamarine, and emerald follow that. Amethyst and peridot, garnet, opal, and lastly, the softest of those is turquoise. Wow. Well, that was pretty informative. Now it's your turn to go in and answer the questions that go along with today's stories. See you again soon. Bye.